Hello my dear students, welcome back to NEET World. So today in this session I will be discussing S block elements for your IPE exam. Okay, so this session is completely focusing on your IPE 2 marks question from S block elements, and I just wanted to note, give a note here. See, first of all, if you are preparing for, if you look into your syllabus, like if for example if you are only preparing for NEET and JEE, so you might be neglected this S block elements, right? Because in that syllabus we do not have this S block, right? So if you are thinking to score 60 out of 60 in your chemistry part, you should not skip this chapter here. Okay, yes, try to focus it on more effectively for 2 marks questions. Okay, from S block elements, yes, we can expect 1 2 marks question. Okay, right. So yeah, so now this complete chemistry, whatever the questions you need to focus for your IPE, I have segregated all of them and we made a book like C60. So this C60 contains all the important questions for your IPE exam. Okay, now you can access this material for free of cost from our NEET World app. So now just go to Play Store and download NEET World app. You just search NEET World app in the Play Store and download it. Then log in using your mobile number. Then you just say your class, whether if you are like belongs to class 11th, you just mention class 11th IPE. If you are class 12th student, yes, you can mention class 12th IPE. Yeah, anyways, this discussion is for class 11th IPE students, intermediate. Yeah, both BPC and MPC students can utilize this. Yeah, so you just mention your group also, so that you will get all other materials also, like MPC Maths, Physics, Chemistry, for BPC Biology along with Physics and Chemistry. Yes, you can access this complete materials through our NEET World lab for free of cost. Okay, right. Now in this session, as I already mentioned, I am going to discuss S block elements. Okay, right. So in the last sessions we have covered from P block elements and all these questions are from where? From this is from equilibrium, like ionic equilibrium, okay, and chemical equilibrium. These things are done, and thermodynamics is also covered. Okay, right. So you just go through them because these are also very important, like calculating pH and all. These are also important for 2 marks. Okay, from those chapters I already made the live sessions on them. You just go through the playlist of this channel itself in the live section. Okay, in the live section you just go and search. Okay, just scroll chemistry IPE first year will be there. You can watch all those playlist videos. Okay, now here I am going to discuss S block. See, what is the first question? What happens when magnesium metal burns in air? See, we know magnesium metals like S block elements are also called as alkaline metals and alkaline earth metals. We know there are 18 groups in the periodic table. The first groups here, first 2 groups here, this side, first A group and second A group, that is like we are seeing lithium, sodium, potassium, rubidium, cesium. So these are first A group. Then next beryllium, magnesium, calcium, strontium, radium, barium. These are second A group. Okay, alkali metals, alkaline earth metals. Okay, just remember them. Now they are asking what happens when magnesium metal is burned in air. See, magnesium belongs to second A group element now. So magnesium atomic number is 12. When it is exposed to air, what happens? Oxygen. It will form respect to oxidized product, like magnesium oxide will be formed. Okay, now remember all these elements, like all these alkaline earth metals, when they combine with any other species, these metals, these alkaline earth metals will be in +2 oxidation state. Okay, whereas if they belongs to first A group elements like lithium, sodium, potassium, whenever these first A group elements combine, they will form +1 oxidation state. Okay, for example, sodium upon exposure to oxygen, what happens? It will form sodium oxide. Okay, sodium oxide. Whereas here magnesium, it will form magnesium oxide. That's it. Okay, and here they are saying when it is burning air. See, we know in air there will be major quantity of nitrogen gas also, right? Along with oxygen, there will be major quantities of nitrogen, around 70%, right? So now what happens here is magnesium also combines with nitrogen along with oxygen. Okay, so that we are going to get a magnesium nitride. Okay, magnesium plus N2 combines to give magnesium nitride. Okay, magnesium nitride, like 3 Mg plus N2 gives rise to magnesium nitride. These are the 2 reactions to be remembered from this discussion. Okay, so look at here what they are saying. When magnesium is burned in air, In air, it reacts with both oxygen and nitrogen to form magnesium oxide, that is MgO, and magnesium nitrate, that is Mg3N2. Okay, this particular representation is important more. Okay, right. So magnesium combining with oxygen to form magnesium oxide. Again magnesium combining with N2 forms magnesium nitrate, that's it. Okay, now what are the oxidation states of magnesium in both cases? It will be +2 only. In both compounds it is +2 only. Now what about the oxidation state of oxygen? Here it is -2, and here for nitrogen, one nitrogen, it is -3. Okay, remember this oxidation states also. Okay, is this clear whatever we discussed till now? Is this clear or not? Yeah, if this is clear, just click on the like button, then we'll move for the another question. See what they are asking, why is gypsum added to cement? Okay, see, gypsum is added to cement. What is the reason behind this? See, when you take only cement, okay, so cement is having like mixture of compounds. Okay, like whenever we add water to the cement, what happens? Fast reaction takes place. What happens? A very fast chemical reaction takes place. Okay, so therefore there is no time gap, or there will be very less time gap to make it proper construction. Okay, so it is very difficult while doing the construction if you only use cement itself. Okay, so now what happens when we add gypsum to it? The chemical reaction between water and that cement will be slower, or it will be decreased. The rate of reaction will be slower. Okay, when we add this gypsum. Okay, so what it will do? Gypsum slows down the rate of reaction or decreases the rate of reaction between cement and water, okay, by forming a layer. Okay, so now just read these statements. Gypsum, what is the formula of this gypsum here? Calcium sulfate CaSO4 dot 2H2O. Okay, gypsum is added to added in a calculated amount. Okay, added a calculated amount to the cement to slow down the setting process of cement. Okay, therefore it will be comfortable while constructing. Okay, but if you are not using this gypsum, what happens? That setting process will be very fast. Yeah, we cannot make it proper construction. That's why it is added. So it prevents the cement from setting too quickly. Okay, if you are not adding gypsum, it will be very fast setting. Okay, that is not suitable while construction. Okay, it is prevents, gypsum prevents cement from setting too quickly by controlling the reaction with water. Okay, this is the main point to be remembered here. Okay, and the next question here, describe the importance of plaster of Paris. What is the important uses of plaster of Paris? See, we can also call it as in a short form as POP. Yes, you are much familiar with this plaster of Paris. Okay, see, when we are seeing Ganesh Mandaps, like while time of Ganesh Chaturthi, we will be seeing this plaster of Paris, that idols will be made up of what? POP only, most of them are. Okay, and during Durga Puja also, during Dasara, Navaratris also, we will be seeing that idols are made up of this plaster of Paris only. Even in the home for decoration purpose, like whenever they are doing some renovation and all, what they will use? This POP for designing purpose they will be using, like interior designing will be also done with this POP. Okay, right. Now what is the formula of POP? So calcium sulfate dot half H2O. This is the exact formula to be remembered for plaster of Paris. When it comes to gypsum, what happens? CaSO4, it is 2H2O for gypsum. For plaster of Paris, it is CaSO4, half H2O is here. Okay, remember the difference. Okay, right. So it is important. Why it is important? Yes, it is used for molding and casting of statues, right now, statues and ornaments. Okay, yes, for casting of statues it is very, very useful. Next one, it is used in used in fracture bandages. Okay, so if you see, if there is any fractures, like bone fractures, if you see, so yeah, some doctors will use it to give a gypsum, this plaster of Paris like as a bandage right now. So you might be familiar, you might be seeing this application in your daily life also. So used in, like POP is used in fracture bandage to keep bones in the position. Okay, right, this is also important thing. Okay, The next one here, it is used for coating walls. Yes, it is used for coating walls also now, and also ceilings for smooth finish. Yeah, so you might be very much familiar with this concept also, this application also, right? Yeah. So these are the some important applications you will be seeing for plaster of Paris, right? Okay. Then next here, describe the important uses of a quick lime. What they are saying, describe the important uses of a quick lime. Okay. So quick lime, what is the formula or composition? Quick lime is calcium oxide. Is it used in following application? So where it is used? In the manufacturing of cement, calcium oxide, quick lime is used in manufacturing of cement, dye, and also Na2CO3 from caustic soda. Okay. So for preparation of this Na2CO3 from caustic soda. What is caustic soda? It is NaOH. Okay, and also used in purification of sugar. Okay, purification of sugar also we will be using quick lime. Okay, and after this, describe the important uses of sodium carbonate. So sodium carbonate, Na2CO3 is there. What is its important uses they are asking? So Na2CO3 having very good application in removal of hardness of water. Okay, so if we extract water, what happens from the earth crust? What happens from the ground level? What happens along with the water? There will be some minerals, there will be some salts present in it right now. So we need to remove them. Otherwise, if it is in excess quantity, what happens? It will be very like causes damages to the vessels or whatever the containers we will be using for storing, and also it is not good for health right now. So that we need to use that extra or excess salts present in that water. So what are those? Especially here, magnesium sulfate, calcium sulfates, or chlorides of magnesium and chlorides of calcium. These are the things which causes a hardness to the water. Okay, so it means we need to remove calcium plus 2 salts. Just remember, calcium plus 2 salts, magnesium plus 2 salts, like group 2 metal salts you can remember. Okay, so that we need to remove. So for removing of these, we can use sodium carbonate. Okay, so what we are using? Sodium carbonate. For example, calcium is there, calcium plus 2 ion is there. So upon adding Na2CO3, soda, lime, what happens? This calcium plus this carbonate forms calcium carbonate precipitate. Okay, this will get precipitated. Yes, we can remove this precipitate out, and we can get our water, normal water right now. So this is how we can remove hardness causing substances from the water. Okay, it is used for removing of hardness of water. Okay, preparation of glass and caustic soda, where will be used? Will be used in preparation of glass and caustic soda. Okay, in laundries as washing soda. So it is used as a washing soda in laundries. Okay, in paper, paint and petroleum industries also it has good applications. Okay, then next, what are biological importance of sodium ion and potassium ion they are asking. Okay, so just read what they are saying. What is the biological importance of sodium ion and potassium ion they are saying. So sodium ion helps in transmission of nerve impulses. Okay, so signaling and nerve impulses here, and here you can see controls the flow of water across a cell membrane. Okay, so sodium ion controls the flow of water across the cell membranes. Okay, and it aids in transport of sugars and amino acids into the cells. Okay, so these are the 3 important applications of sodium ion. Similarly, we have 3 important applications for potassium ion. See, it helps in activation of many enzymes. Okay, so potassium ion involved in oxidation of glucose to produce energy. Okay, next, it helps in now signaling transmission, signal transmission. Sodium ion helps in, potassium ion helps in now signal transmission. Okay, remember this three points for each of the ion. Okay, so next mention the important uses of magnesium metal. Yeah, guys, before this, see there are 15 questions in total I have collected from this S block elements. First you cover these 15 questions, then you can go through other questions if you are really wanted to look few more questions. Okay, mostly these 15 questions are must do, only because we can expect question from this 15 itself. If not, if you want more, yes, you can go through any of the other notes like your books or any notes if you have. Yeah, you can get more questions, but first you cover these 15 questions, maximum these are sufficient. Okay, and you can expect question from here itself. Okay, so mention the important uses of magnesium metal. See, magnesium forms alloys with aluminium, zinc, manganese, tin. Okay, so what they are saying, magnesium can form alloys with aluminium, zinc, manganese and tin. It is used in magnesium used in flash powder, signal flares and bulbs. Where it is used? Flash powders, signal flares and bulbs. Magnesium carbonate MgCO3 is used as an ingredient in toothpaste. Okay, you just take any toothpaste and just check what are the ingredients we have in that. Okay, so one of the ingredient here is magnesium carbonate in the toothpaste. Okay, apatites will be used along with that calcium carbonate, magnesium carbonate is used. Okay, what is the importance of calcium in functioning of cells? So what is the importance of calcium in calcium ion in the functioning of cells? Okay, first one here, calcium plus 2 ion is an important part of bones and teeth. Yes. Okay, yeah, because bones and teeth contains this calcium ions, right? So it helps in regulating heartbeat. Calcium ions are helps in regulating heartbeat. It is required for bleed clotting. Okay, blood bleeding now. So during that time it should get clotted. So for that required thing is here calcium plus 2. Okay, required for blood clotting. Okay, the next, essential for muscle contraction. Okay, calcium plus 2 ion is essential for muscle contraction also. Okay, right. Next one is, what is baking soda? Give its uses. Okay, give its uses. So baking soda here is nothing but NaHCO3. So previously we have seen washing soda, Na2CO3. Here it is baking soda, NaHCO3. So where do we using this? Yeah, so it is used while baking, like in bakeries or even at our home when we are doing any bakery items, you can say we will be adding this baking soda so that it will get a puffy way, like cooking will be very like puffy manner. Okay, so look at this sodium bicarbonate, NaHCO3 is called baking soda. Okay, so it is used as an antacid in medicine. Yes, it has a good like usage. Previously it is used as an antacid in the medicine. Okay, now used in effervescent liquids. Okay, drinks. Okay, used in fire extinguishers to release CO2. See, in fire extinguishers we have NaHCO3. What we have? Sodium bicarbonate we have, and along with this some quantity of sulfuric acid we have. Okay, so whenever this mixture is, see, this will be separated in like a containers. So in that fire extinguisher cylinders, if you observe, there will be NaHCO3. Okay, at the top we have sulfuric acid. So whenever you are pressing that knob, this sulfuric acid will falls into the NaHCO3. Now that releases CO2 gas. What it is releasing? CO2 gas. So this CO2 gas, whenever you spread on the fire, it will be getting off. That fire will get put off. Okay, so used in fire extinguishers to release CO2. And the next, used in baking powder. This baking powder is used in cooking and also for making cakes. Okay, that's it. Next, again, what is plaster of Paris? Mention its uses. So we already discussed plaster of Paris is calcium sulfate hemihydrate. Hemi means half hydrate. Calcium sulfate dot half H2O. Okay, used in surgical bandages for bone fractures. Okay, used in surgical bandages for bone fractures. Okay, used for making white chalks. used for making white chalks. Okay, used to make cost for statues and roofs and toys. Okay, we already discussed about calcium, plaster of Paris. So why is gypsum is added, already discussed, no? That's it, that is also over. And the next one here is, so why, this is again, you can highlight this, why alkali metals are not found in free state in nature. So why these are not found in free state in matter? Because alkali metals are highly reactive. They are highly reactive. What are the alkali metals we have? Lithium, sodium, potassium, these are. So if you observe, you cannot see these compounds like these elements in their free state in the nature. Always they will be in their combined state, either in their salt forms or in their oxides forms, but they never be in the free states, because whenever they expose it to air, what happens? It gives an like exothermic reaction also. Okay, whenever it is exposed to some moisture content or water content, okay, what happens? They will give an exothermic reaction and forms respective oxides. Okay, right. So alkali metals are highly reactive. Yes, highly reactive due to the presence of one valency electron. See, for example, sodium, if you take atomic number 11 now, so if I remove one electron, it becomes neon gas configuration, and this 3s1 electron will be goes out. Okay, if we remove this 3s1 electron, it will get a 10 electron configuration, neon gas configuration, noble gas configuration. No? So that's why this sodium or this alkali metals always try to undergo some chemical reaction, and they loses their electron, this extra electron, and they becomes the noble gas configuration. Okay, so alkali metals are highly reactive due to their low ionization energy. So ionization energy means the amount of energy required to remove this outermost electron. Okay, if low ionization energy means more easily it is giving out electron. So it has a low ionization energy. Okay, each atom has one electron in their outermost, like this. Okay, all alkali metals, lithium, sodium, potassium, rubidium, all of them have one outermost electron. Okay, which is easily loses to form a positive ions. Okay, once after losing that electron, it forms a positive ion. Okay, so hence they always occurs in combined form as compounds like NaCl, K2CO3, and not in their free state. Okay, they won't be in their free state, they will be in the combined state when you consider in the nature. Okay, right. Now what happens if I want to add an extra point? What happens? Reactivity down the group for alkali metals increases, because the large size at the bottom, so more reactivities, because it is easily loses its valency electron, that extra electron. Now here we have one more question. What happens when magnesium is burned in air? Already we discussed in this question, right? Yeah, these are the last two questions we have from S block elements. Okay, so what they are saying, why can't potassium carbonate be prepared by Solvay process? So what is the use of Solvay process? Solvay process is used for preparation of NaHCO3 things, right now. So the Solvay process is not suitable for preparing K2CO3. Okay, reason, potassium bicarbonate, here potassium bicarbonate is highly soluble in water when you compare with the sodium bicarbonate. Okay, since it is more soluble, that's why we cannot able to prepare this potassium carbonate. Okay, right. Hence see, whereas when you compare with NaHCO3, yes, it is less soluble, so it is prepared from this soda Solvay process, but not KHCO3. Okay, so that's why KHCO3 cannot be prepared separated by filtration, and K2CO3 cannot be obtained. Okay, since it has more solubility, potassium bicarbonate has more solubility, we cannot separate, filtrate out, therefore we cannot get this K2CO3 from that. Okay, the next, what is the last question? Why does the solubility of alkaline metals, alkaline earth metal hydroxides in water increases down the group? So what they are saying, alkaline earth metal hydroxides. What are the alkaline earth metal hydroxides? Here we have, so you can say beryllium hydroxide, okay, +2, magnesium hydroxide, okay, and the next calcium hydroxide, like this we have. So down the group if we move, the size of metal increases. since size of metal increases, they will be having more ionic nature. Okay, as we go down the group, what happens? They have more ionic nature. Barium hydroxide is having more ionic nature. Okay, ionic compounds are more soluble compared to the covalent compounds. Okay, here if you say beryllium hydroxide have more covalent nature and this barium hydroxide have more ionic nature, therefore it is easily soluble. But you just write as it is, whatever. See, this is how you can understand the concept easily, but you also mention in this way, as the size of cation increases, yes, down the group, as we go down the group, size of cations increases. The lattice enthalpy decreases more rapidly than hydration enthalpy. What happens? Lattice enthalpy decreases more rapidly than hydration enthalpy. Hence, the overall energy change favors dissolution. Okay, favors for dissolution, and solubility increases down the group. Okay, down the group solubility increases for hydroxides due to the increase in their sizes. Okay, due to increase in their sizes, they becomes more ionic and more soluble. Okay, that's it. Okay, now whatever we discussed till now, you just go through them once again, make the notes for 2 marks questions. First cover these questions we discussed now. Okay, then later if you have time, yes, you can go for the other questions also based on your interest, but these are the must do questions. Okay, mostly these are enough. Okay, right. So we'll meet in the next session. Okay, so yeah, we have few more things to discuss from other chapters also. We'll cover them everything, do not worry, but stay connected with our NEET World channel, and if you are new to this channel, click on the follow button, and you can share with your friends who are preparing for IPE exams. And also guys, I just wanted to mention, if you are class 11th, yes, definitely you are class 11th. Okay, so start your preparation for NEET, JEE and EAP set from now itself if you haven't started. Okay, yes, and we are conducting free live sessions for EAP set also in this YouTube channel itself. You can follow us. Okay, and you can make your preparation more effective and more productive. Thank you for watching. Stay connected. Thank you.